This is really fascinating, and I think it applies to data science and other areas. My prediction is that other areas of business, government, and life will become also battles of the algorithms. That has a lot of implications we haven't even been able to think about yet. But I think as data science evolves, we need to have a code of conduct, and we have to really understand how we're designing these algorithms and how they behave as they execute in the real world. It's not like you can just design an algorithm, push the button, send it out, and sit on the couch and eat potato chips and watch football games. You have to constantly watch it, modify it, and that's actually where machine learning comes in, because as new data comes in, you have to constantly adjust for it and modify. And in many areas, the amount of data is just so large, it's overwhelming for the human mind, so you have to have the machine helping you. So I think this is going to be a huge, exciting area in the future. Thank you so much, Lee. I'd like to introduce Charles Clifford, who will be talking about machine learning with Google BigQuery. Charles is another good friend of mine, and we also sit down and debate these issues for hours, and it's a lot of fun. Thank you, Charles.
Just give me a few minutes. I'm going to connect the monitor to my PC.
I have a little bit of changes on my a few changes on my slides I wanted to share with you. We'll run on the open.
Control L.
A little bit of background on myself. I started working with relational databases in the late 80s. Matter of fact, I put the first Unix box here at UCG. The first was installed. Went on to build distributed systems in capital markets on Wall Street. I worked in telecom, did pure and applied research there. Other than financial services, I've also worked in healthcare. The past year, I've been working with GCP, BigQuery, on data analytics and some machine learning. So over the past year, I've gotten some experience with this, and I've been talking with Michael about it. And so he's asked me to give a presentation. I started putting out a series of blobs. Should probably stay in front of the camera. I like to move when I talk. So let me try this standing still. I put out a series of blogs on this on my own company website and on my own LinkedIn website. The first series was really more for the engineers. It was Python programming with GCP stack. And now, so I'm going to continue that series. There's going to be a couple more coming out that are going to deal more with the lower level engineering issues. Today's talk is about some of the better practices that we need to make sure we're doing when we're doing big data projects as well as machine learning. And I'm seeing a lot of missteps take place. People are not putting enough due diligence. So a lot of this conversation on this presentation tonight is about some of the notes from the field about things we want to do in order to be successful at approaching this. So what we've found over the past year in the projects I've worked with is that BigQuery's ability to handle large volumes of data make data exploration very easy, and text classification surprisingly easy as well. But there are issues around BigQuery and GCP. It's pretty much new to the public. So BigQuery itself is new, relatively new. People fail to appreciate the fact that when you say a data service, it doesn't necessarily mean it can do things like update your data or delete your data. So when you think about using these NoSQL data service, particularly BigQuery, you really have to look at your use cases and find out whether or not it's a good fit. And that's where most people miss, is they don't really look at their use cases. Another thing I found too with and the other people on the team, this is really, the presentation and the blobs are a reflection of 3 or 4 teams I've worked with and other people's findings and their feedback shared with me. There's the Cloud SDK for GCP, and there's the App Engine API. My experience was with primarily with the Python App Engine API. Unfortunately, it's badly documented, so you have to plan on doing a lot of low-level walk-through on the code. And the Google training it is not really up to snuff. All right? There's a stark absence of players in the field, so if you're going to do this, you really have to get ready to dive into the SDKs, and this is why I put out the first series of posts, my last series of posts is going to be down into those APIs, down into that code level. The one I put out to load from on-premise to the Google Cloud Storage had over, I looked this morning, had over 700 reads. And that was the version of it in LinkedIn. So who goes to LinkedIn for code? So really, there's a dearth of other helpful information on this, so I'm trying to fill that gap. But you have to plan on spending a lot of time, what I would call reverse engineering, because the documentation doesn't take you there. The training doesn't take you there. You have to figure it out, and there's not much code samples. The APIs, what we were using with past years, there were lots of changes taking place. Python language, by the way, is the very first one they port to and they write to. So you're getting, if you use the Python stack, you're getting the latest and greatest. There were quite a few changes. A number of them broke the stack, but for the most part, the changes are improvements. So you have to be patient with the stack. All right, it's a lot of power there, a lot of features that you're getting, but just be patient with it. Now, Google BigQuery comes out of the Dremel project at Google. It's a highly parallelized data service, runs on your commodity services, basically VMs on top of commodity services. It's column storage, not relational. There are no indexes supported in BigQuery. So you're down and constantly scanning your disk, which really is going to influence how you're going to design your schema. Particularly if you have long time series data, which, for example, one of the projects I had 15 years of daily transactions to look at. And one of the next postings I'll put out, blob I'll put out, is the conventions from a data structural standpoint that you want to design, and then the last one will be the code and actually how to do that, how to write the algorithms to handle that. Large data volumes get to be a problem, and how do you process them in a timely manner. Within Google Cloud Platform, you start with a project. That's where all your billing goes to, that's where all your users go to, and then in BigQuery you create data sets, and that's where you can isolate individuals into data sets. It's not that robust a security layering effect that you would see in, say, a relational environment. So keep that in mind when you start bringing data in together that you want to make, empower people to explore. Okay, you have to really plan on who's going to be able to look at what. You access BigQuery through a web-based GUI. I found it was very easy to pick up and learn how to use. Very dependable. Didn't have any issues with it. There is, however, when, in my case, thousands and thousands of data files coming in, thousands of tables, you get this high latency as you start scrolling back and forth. That was the one objection people had. But a very stable, very robust user interface. You also have command line scripts you can write to. Your Cloud SDK is very powerful, very easy to pick up. That's somewhat better documented than the REST APIs. Those you have to program, and the first code sample I put out dealt with working with the REST API for Google Cloud Storage. The second two will come out dealing with the REST API for BigQuery. Now, BigQuery has SQL, as we've heard, and we've all known SQL is a very common language. But I put question marks behind it. Every one of these no SQL data services that give you an SQL-like language. It's not the SQL you're used to, and in some cases, based on your use case, that can be a good thing, okay? But don't assume it's SQL. Not only am I picking on BigQuery, but any one of your NoSQLs that say they have SQL, really have to look at the syntax. Now, with BigQuery, most everyone, other than people with my experiences deep in relational, when you move over to NoSQL and BigQuery, we want to look at these services from an RDBMS perspective or mindset, for right or wrong. But when you're looking to use a new data service and you have those backgrounds and you're looking at your use cases, you really have to very quickly identify what these things can and cannot do. Because what they can't do has a huge impact on your budget, your timeline, and what you can actually accomplish. So the first thing to understand is that no updates are provided for you. Okay? You cannot ask this data service to do an update of anything. That means you have to handle all those updates outside of BigQuery. Now, anybody who's tried to do random writes by hand, it's very complex, which is why it's not present inside BigQuery. Google engineers are extremely good in my experience, top-notch engineers. If this problem couldn't be solved by them, it's a serious problem. Okay, so don't take it lightly. So I'm going to have a series of posts about the algorithms, data structures, and actual code on how to do this. Now, you can't go out and buy an ETL tool set to do this because none of them scale. Okay, none of them off-the-shelf scale. All right, so you're going to have to basically do this by hand. You have to make sure it's fault tolerant, highly schedulable. Hire a software engineer if you don't have one. This is a software engineering problem. It's not somebody who knows how to use an ETL tool problem. Okay? You're going to want to adopt source code control tools too as part of this effort. So you manage these codes, because what you're going to write are little tiny microservices. They're going to run in parallel, distributed across the cluster, next to the data that does their computations for you. So you're really building a little tiny software system to handle these updates. So plan on that. You're going to want to determine whether or not you want to do this in GCP, on that platform itself, or if you want to do it on premise. And we'll talk about that in my blogs, differentiate it. Now, just the same types of problems you have with, consequently, because updates aren't supported, deletes are not supported either. Okay, so you have to programmatically do the updates, you have to programmatically do the deletes, if that's relevant to your use cases. Now, what we saw is that there's generally a high latency period between your data source and BQ. Okay, you're not going to get it like this. So plan on your use cases. If you can have a couple hours of latency, an hour or so of latency, in your use case, it's fine. If your time frame is really tiny, less than that, let's say, for large data volumes, you know, I would say tiny is less than hours. Right? So you have to look at your use case, look at your data volumes, how fast you can move the data, and make that as part of your determination as to whether or not you want to do this in the cloud with a data service such as BigQuery. Now, when you use Google BigQuery, you also have to purchase the use of Google Cloud Storage. That's your data storage platform. That's where you're going to upload all your data into, and then from there load it into BigQuery. Now, since arbitrary queries are not supported, you don't have indexes there, right? So you can't do your arbitrary queries. You end up having to scan everything. And I'm pointing these out because this is going to go into your physical design of your data sets that'll feed into your machine learning algorithms. You have to basically create custom pre-computed materialized views. Anybody from Oracle land? Be a similar term, right? You have to programmatically do that, okay? That gives you the absolute best performance, and I'll give you a couple examples as to why you'll want to cross that. If time is of essence to you, you're going to want to cross that over programmatically. BigQuery, go look at the, there's one page where they have the syntax. It's rather terse. It's for somebody who knows SQL. There are no cookbooks, very few examples around it. But take a look at that syntax. Particularly if you're a business analyst and you're now going into a big data arena and you're used to using one or two other versions of SQL, please go study that reference and ask yourself, do I have all of those syntax support that I'm used to having for my use cases? Because if it's not there, you're going to have to adopt a different language to use. Now that could be a good thing for you, the features of it. BigQuery's SQL, or it may not. You have to look at that on each individual case. But I made this point, you would not think of taking an enterprise data warehouse or a data mart and porting it up to BigQuery because of that SQL problem. Look at that really hard before you make that consideration. Now, with BigQuery, you can bulk load new data into a table like that, particularly through the GUI. You can do it programmatically, very fast. 4 gigs, 78 columns wide, a mixture of strings and characters. I had it in like 8 seconds. Really fast, super fast. Very, very dependable. And you can also append large data volumes like that in that short amount of time onto your data sets as well. Very nice feature. I don't know if you've ever had to administer globally distributed database systems. I have. I love the fact that I don't have to do anything administratively with this. Right? I can just focus on my algorithm. I can just focus on my use case. I don't really have to concern myself with any of the operations below it. So you don't need to bring a DBA onto the team or database developer onto the team to do it. Now, I'm saying here tens of terabytes. Now, let me explain that. That's not a big amount of volume for BigQuery. It's not. But I'm talking about tens of tables in third normal form with tens of terabytes in them, doing a join across them and getting the data back very quickly. Financial services company had a query that was running in Oracle at 2.5 hours to 3 hours. Okay, I took that slight modification of the SQL because of the differences in the language. I brought that down to 14 seconds in BigQuery. I then rewrote it, the query, so I wrote the data set the way I wanted to read it, brought it down to 4 seconds. I've never seen anything like this. That type of power at that low volume of data means that you can take a third, in my opinion, a high probability, I'll take a third normal form OLTP system I want to do my analytics on, take that schema, recreate it in BigQuery, throw my queries at it, and get my data back much faster. Very sweet spot. I bet you anything financially, the cost of doing it is much less expensive than having a clustered SQL Server or a clustered Oracle Server on. So if you're doing that type of thing where you've got a third normal form OLTP source system, and you want to start doing analytics on it without going through this whole denormalization process, doing updates of denormalization structures and star schemas, you want to avoid that, and you've got these size of tens of terabyte tables, try this out. You'll have good luck with it, good results. One thing you do want to do is avoid subselects, though. It's kind of, I don't know, less dependable area. I'm hearing a lot from people that some of these subselects are having problems. So if you do have these subselects in your queries, write it the way you want to read it, and then you'll avoid that subselect problem. Now, what we did see is that there are very powerful text query capabilities within BigQueries. You have your SQL to which you can append regular expressions, which is fantastic. I don't know if you've ever had problems with processing data with regular expressions that are going to be merged with SQL. You pre-process with your regular expression. You can do these to combine together. And this is one machine learning context we'll talk about a little bit later that is very helpful. You also have within most business domains nested hierarchies. Human beings just naturally form hierarchical structures, and then we create pseudo-structures that are also hierarchical, that we function within. We create business models and domain models that are hierarchical, right? So you try to take that hierarchical and you put it into relational, it's a nightmare, right? Try to convert that and keep it algorithmically, every update, delete, insert, creation, read, correct, very difficult. When you can take your structures that are nested, your domain model where you have nested structures, you can take those nested structures as is and place them inside Google Query to great effect. That means your business people who understand their model and see their domain as nested entities, they can go quickly into BigQuery and see the same thing. They don't have to try to rethink their domain in a third normal form or in a denormalized form. The other thing we found out too is that widely different, dissimilar structures can be brought together very quickly within BigQuery. You can support unstructured as well as structured data, very amenable to that. That was a very positive experience from it. Now, the funny thing about going into the cloud is that you still need to be very grounded in what you're doing. Okay? To do that, you need to look at your business use cases, and within big data and as within machine learning, you're seeing the same thing, is that people are going up into the cloud and they're not grounded. Okay, they don't have their business use case established. You want to stop and think, what is it I want to do for the business? Is this technology, this collection of technologies going to help me out or not? Okay, because that's the only way to avoid what I call buying a fool's gold. Right? You're making an investment in something you didn't do your preliminary due diligence on. A lot of people now, because they're very enthusiastic about these efforts of big data and machine learning, they're over enthusiastic and they're not stopping and thinking. And a lot of these big data and machine learning projects are failing because of that over exuberance. So what you want to do is have an explicit understanding of your business objectives. Okay, you'll get that from your domain manager and your domain subject matter experts. They know it. If they can't make that objective explicit, you're going to fail. Okay, it's got to be sponsored by them, and you don't need a business analyst to do that. You just need your domain experts and your domain managers to do that. What you want to do is put this down in writing so everybody has a meeting of the minds. Why are we involved in this ML project? Why are we involved in this big data project? You want the language to be ubiquitous in business. It's very critical that that written document be there so you can start managing your risk, because you're going to take that written document at a high level. I call it the mother use case. It's an abstraction. You're going to deconstruct that down into 2-week deliverable sprints, so it helps you with your project planning. But it really helps you to manage your risk. You'll see a lot around proof of concepts with machine learning, proof of value for big data as well. Well, if you don't have a use case with a clear business objective, you've proven nothing. You have no proof of a concept, you have no proof of value. So stop and think about it. Now, what's the criteria of a good business use case? Projects that succeed in this area, and any new undertaking, I've been involved in all the stuff that's come out in the 80s. Only those that had real value of a use case succeeded. I don't care how complex the problem is. I mean, Richard Siegel and I put out a derivative system globally. We were the first ones to do that. Very complex problem, but we had real good use cases. So a use case helps you deal with simple problems that are usually complex. Everyone on the team, it's a mindset. Everybody has to share those values and give them focus. I would always recommend you know what your return on your investment is. Even if you're doing R&D, you should tie it to the acquisition, preservation, and growth of capital. Even if you're in an R&D group, why are you there? What are you doing this for? And you only want to put people on the team who can shoulder that duty to deliver that dollar value back. Okay. Next, it should be testable. Right? I have a use case, but as a business person, consumer, how am I going to verify and validate that this machine learning algorithm actually does what it's supposed to do? Right? So as I say, unless you know what your tests are, you don't know what your finish line is. You'll never know when you're done. You never know if you've made it across the finish line. So make sure it's testable and verifiable. And you'll take that mother use case and you'll give it to your engineers, who will then deconstruct it so that they break it down into testable, deliverable units every 2 weeks. Sometimes, 1 week, sometimes 3 weeks, but at the end of that, you should test to verify and validate it, bit by bit. Now, for those, anybody here familiar with the domain modeling? It's still kind of new to people. Okay. Very, very powerful technique. Very, very useful technique. It starts with the team, has your domain managers and your subject matter experts, like your team members. What you want on the team are people who will continually innovate. This is really important in machine learning, and particularly with the machine learning, but big data, because there are so many new cutting edge practices. You have to have people who have a mindset of saying, okay, so I did this for decades. I mastered that. Whoop-de-doo, this is a new problem space. Let me open my mind up to thinking about it in new ways. Let me not project onto this new context my old school way of thinking. Let me open my mind and see it differently. So you want people with that type of mindset. And you also want people from the business standpoint who want to innovate, because unless they want to innovate, you'll get your actionable, the marketing term now are actionable insights. They'll just stay that. They'll go nowhere, right? They're not going to disrupt their business channel. So as a machine learning expert, look at, this is a political statement now, look at the domain managers and the domain subject matter experts, size them up. Are these men and women who really want to innovate, who really want to disrupt? Because your machine learning algorithm will shine a bunch of lights on and start disrupting things. You'll start being able to quantify and verify what's actually going on, as opposed to what people imagine or believe based on your intuition. The other thing too is you find out with machine learning piece is that it has to get really small in scope. Very, very small in scope. Needs to have a small scope because your machine learning is typically tied to some market behavior which is constantly changing on you, out of your control. So you need to have a small set of microservices, small collection of services that are highly malleable and changeable. Okay? So keeping that in mind when you're doing these. And testable. They have to be empirically proven that they meet these results. For those who are from the data science standpoint, you think in terms of ontologies, your domain model is an ontology. Right? So when you sit down with your business people and you want to start looking at opportunities to create these machine learning algorithms, you can talk to them in terms of ontology. Most people won't. Business people won't. Business people understand domain model a bit better. Now, when you have this domain model built up or you have your ontology built up, most often you express it as an object model. And this is really key when you start using BigQuery. You'll take that object model and you express it as JSON, because that JSON representation is going to be your BigQuery table, an entity. Okay, so it's a very strong way of taking your domain model and immediately materializing it. Immediately materializing inside BigQuery. And filling it with large volumes of data. Like, my client was absolutely surprised just how fast we could load 15 years of data into this. And then do my analysis for 15 years of data. And they were, in that 2.5 hours, they were looking over, that query was looking over only 3/4. Before, they had never had the opportunity to look at the data over this large time frame. So keep that in mind when you're thinking about these, your domain. How are you going to represent it as JSON document that the business is going to say, yeah, that's our domain, and then you're going to express it inside BigQuery. No updates, no deletes. You have basically only snapshots. So think in that terms of with your machine learning algorithm. Is that the type of data you can use for it? So now what you'll find is that from Google Cloud Storage, you're going to truncate your table in BigQuery, do a bulk load of fresh data, and that's generally what you'll be doing. Otherwise, you can append onto that new data sets. You're just adding them and accreting them onto the existing data set. That method is supported by BigQuery's console, which is web-based. As I said, it's very easy to learn, very dependable, very consistent, but it's too labor-intensive. You want to start moving from machine learning and start doing some type of loads in a production standpoint. You're going to have to go down and start doing this programmatically. Now, although I said the APIs were rapidly changing and not well documented, the parts of it that are very stable, the parts of it that are reasonably well documented, particularly if you start looking at my code, which really lays it out at the lowest level of granularity, you'll find that it's very easy to do this programmatically. Excuse me. Once again, your JSON representation is going to be your BigQuery table. I'll use the term table and entity. It's really an entity if you're used to objects. It's really an entity as opposed to a table. It's got all of the relational aspects of a table, but since I can nest other entities in it, we're talking about nested hierarchies, nested entities. Next, you can use CSV input files. This is most common with your large data, or you can use JSON format. JSON format adds a lot more overhead to your data, right? More metadata around your data. But one nice thing about having a JSON representation and your CSV header file, CSV always put a header file in that, is that that's your specification to the person who's going to be doing your extract. Give me the data just like this, with this header file on. Next, remediations. via conventions. Anybody here used the model view controller? That works based on conventions, right? It's really powerful because there are certain conventions that are adopted. Try to do a model view controller without a convention. Good luck, right? It's hard. So there are conventions for this, and as I mentioned, the other blobs will get into this, my other postings will get into this, but this is your classic way of partitioning your data by time. Do it, but you can add hours into this, minutes, seconds, nanoseconds, however you want to partition it out. So you're going to have one partition of the table based on some slice of time. So you'll have one partition, one BigQuery entity. Now to make this consumable, so that people aren't inundated with literally thousands of partitions, you'll create one view over all of them. So they'll do their computations against one view. It's transparent to them, it's immaterial to them that there are literally thousands of partitions underneath that one view. Google App Engine. It kills a process that runs for 10 seconds or more. So don't think of using it for doing updating of large data volumes. I tried that, been there, it doesn't work. Google Data Flow. It is a new product, a new service, I should say, from Google. It is an idempotent RESTful API, which means that your client's going to continually, repeatedly invoke some behavior, okay? And it should be immaterial to the outcome if it's repeatedly done. Well, that's not how ETLs work or ELTs work, okay? So, you know, it's a new service. Take a look at it, take a look at the documentation, and make a call on it yourself. Update delete process are typically disk I/O intensive, which means you're going to want to get those on solid state devices. That's my experience. That's the best way to go for right now, solid state devices. You want to co-locate your data files with your computations. You want to avoid, for example, you don't want to put the data sets on NFS, say if you're on premise. I don't want them on NFS and I have my computations here. I want my data and my computations on the same box. I do not want to move anything over the network. Now, the other piece with BigQuery is there's a streaming API that's coming in where you can accrete, not batches, but individual records onto it. When I was working with it, it was not yet product, somewhat unstable. It didn't work as documented. I know they're making improvements on it. I can't speak from it now. This goes back to May and June. Now, domain model versus your business domain model is going to be your BigQuery model. There's not going to be two separate models here, which is wonderful. If you know the business, you'll see that structure in BigQuery. You won't have to go through this denormalization process. Now, what you want to do in all big data efforts is to go into, learn the lessons from data warehouses and BI debacles. Okay? I think if anybody familiar with a report that came out about 2 years ago, businesses say 80% of them weren't worth the value, didn't deliver. And a lot of that happened because people took more than one domain and merged them together. Right? Avoid that now. It's seldom that you'll find leadership in two domains that will want to work together with you on a project. Okay? Because usually they're comped differently. It's really what happens. Also when you start blending different channels in, you're going to get scope creep on your machine learning happening on you. Things are going to start getting out of your control. So keep within one business domain, make your deliverables there, make your success there, and then reproduce that on a separate business channel within the enterprise. Now the last part is that if you already have your schema in place within BigQuery and you're going to start adding more to it, then you don't have to go through the domain model process again for every use case. Okay, data exploration. This is where the real strength I saw and the rest of the team saw with BigQuery. The ability to explore data sets from a wide variety of different sources very, very quickly through their, and very easily done through their GUI API. We use it to transform very large volumes of data into a representation suitable to ML. Now, when I was saying you can't do updates, you can do your queries and joins and take these different sources and output them into a very nice, desirable structure that you want very, very quickly. BigQuery's console and API can support exploratory steps in that too. So if you've got large data volumes and you're not really quite sure what's there and you want to explore it, and start looking at it, drill down through it, this is very helpful to do that and very quick at doing that. It can store very large numeric summary tables very nicely. So you can do your classic statistical data collections, and supports that quite well. Data source for basic visualization, to search on patterns. Very powerful to collect, I should say, to collect the data that feeds your data visualization. Very powerful on that. You also have your basic mathematical functions that you'd like to see in ML within BigQuery's SQL. Another area where representational sampling now is a little bit different skew. When you're doing representational sampling, you're dealing with really a small set of data, right? Imagine you can go through 15 years of data very quickly. So you're not dealing with small representational data sets, you're dealing with rather large, much larger ones. So your ability to accurately predict or actually draw correct inferences is much better. So even though you're dealing with very large, you can still think of representative samples. Correlation research, being able to examine many variables simultaneously was a positive feedback we got back from the analysts. Okay, next one. Passive conformatory data analysis. Table support tests for formal models on the patterns you thought you found in the data. Okay. So it's very amenable to start testing I think I see a pattern. Let me now start building my machines to confirm this and make predictions off it. Next, text classification. This is probably the biggest win because of the ability to embed regular expressions. One client was looking at comments on delinquent accounts and seeing how comments changed over time based on the person's ability or probability of going to pay. So when do you start writing off the bad debts? Basically just looking at how is someone talking about, responding and commenting about how they're going to handle their bad debt. Very, very, very insightful on how people will use language by convention, give you an idea of where they're probably going to start failing when their language starts to change. Now, the thing about text in BigQuery, though, is that most often in like comment lines, somebody will be typing something, you'll hit a carriage return and put a new line in there, right? So you have to, if you're going to do text analysis with this, you have to clean out those new lines. If you attempt to put in a text field with a new line in it, it will think that's the column. It won't assimilate. It'll end of your record, all right? So you got to clean all that out. You got to process all of that out there. There's also issues around double quotes and such. Won't get into that now. I'll get into that blah. But you got to do a lot of cleaning up of the data. Also very helpful in building that vocabulary. I was saying, well, how is the person talking about paying their debts? Is their vocabulary changing? And if so, in what direction? Is it probably going to not pay me or probably going to pay me? So this was very helpful, and also the MBC night-based classification was also positively supported. So in closing, let me just say that you really do need to know your machine learning, particularly with big data sets. You really have to know your use cases. And so look at the ability, the BQ's ability to support certain of these tasks I just talked about that are common to machine learning algorithms. I think you'll find that it's very helpful along those lines I just described. But you want to avoid any hard project deadlines at this point, okay? Because it's not well documented. There are very small community users, right? Who would have thought that you'd go to find code on loading Google Cloud Storage and LinkedIn, right? But the fact that I had, so many hits on that goes to show you that there's not that much out there to help you out. Understand limitations and features of BigQuery. When you want to load up data fast, boom, it's like a vacuum thing. I've never seen anything like it. You want to query that data fast, never seen anything like it. But if you have to do your updates or deletes of that data, it's going to cost you, literally. And then find people who actually know those algorithmic computations. It's even harder. Well suited for transforming very large data sets very large data sets, very well suited for that. And for exploring those very large data sets as well. And for text classification is very helpful. Now, is BigQuery ready for the enterprise? I would say not at this time. And when I say what means it's ready for an enterprise is multiple business domains. When you're combining, you have an enterprise data service, you're combining multiple business channels together, multiple domains together, which means you're updating, you're deleting, you're blending within it. Teradata Aster is an example of that type of thing. You have to blend the data. It's not ready for that. If you have a single business domain, okay, it's ready for that. That's why I say it's good for department level, good for doing R&D. Now, where I think we'll see a lot of future work going on is with Spark, somewhat with Dremel, Apache Hadoop, and Mesos. That's my current area of focus right now. But these very large data volumes, you have to use distributed, highly parallelized data services. So I recommend you take a look at BigQuery along these lines to support these types of machine learning computations. And if anybody has any questions they'd like to ask, open to it. Yes?
So 2 questions kind of related on data formats. So if you want to visualize this data, do you use JSON to go into some visualization modules? And secondly, my understanding is that ARFF is machine learning kind of a standard. So do you use that in BigQuery also?
We did not use that with it. That would be, you'd have to gen that up in a Docker container, basically. That tool, it's not in the environment, you'd have to spin one up. So you'd have to create a compute engine, install it on there. The API between that, I don't know if there's an API between that and BigQuery, but if it's a REST API, then you're fine. It should be just fine. And your first question?
I think you might be answering. How do you visualize the data?
Oh, well, D3 was used to great effect.
Okay.
There are different visualization tools. Tableau I saw used. I saw Excel used too. I mean, that's in there, but not as powerful visualization. But that was also used to great effect. Yes, sir.
Yeah. You mentioned about doing this query, when you've got everything highly normalized. Is there like a 1 or 2 sentence reason why it can do it that quickly? I mean, it sounds like you're putting it in a relational model. The data is sitting in a relational model, but you're pulling it back that quick.
Well, it's not documented, so it's not publicly explained, but I would infer this, is that when you're loading it, it knows how to partition the data for you and spread it out, okay, and balance it across these different disk resources. A virtual disk, it's not co-located with your compute engine. But they also, internally, move the computation to where that data is. Okay. And then they bring back a smaller subset and then merge it together. So it's the old rule of divide and conquer, right? Break it down tiny data sets, compute the little individual data set and then bring it back. That type of answer is not documented. It's kind of like the secret sauce. But if you look at it and you look how other people are solving that problem, it's probably along the same lines.
Okay, so it's kind of how the model is constructed to begin with.
Yes.
That all that computation, everything, it gets put together so that it can bring it back quickly. Is that correct?
Yeah.
Okay.
Yeah. Now, when I went into this part about doing partitions, then I was thinking a little bit like, hundreds of terabytes of data, where I had to actually do updates of hundreds of terabytes of data, do random updates on it. Mm-hmm. So then I had to purposely go out and start partitioning things at very smaller levels of granularity, and then uploaded them at those lower levels of granularity and built a view over it.
Okay, thank you.
So, sounds like the business case or the use case of BigQuery is something that you're going to repeat a fair number of times. You have a domain model and you have your use case. But if you're really going to sink all the development resources in, you need to be able to make use of what you've just invested in. And
which gets back to the value. you know, it's a value proposition, right?
Yeah.
You know, you want to make sure it is a compelling, quantified value proposition.
But shouldn't it also be, you know, part of the value proposition is that once we have invested all of our development time and money and resources and opportunity costs into doing something that we can do in BigQuery, we have enough that we can leverage it easily to the next thing.
Right. Yeah. You know, I think of coming on Wall Street, I think of getting money in a very short time window. I mean, some people have longer shelf life for their value added. Depends on your business domain. But, you know, what you'd hear on Wall Street, came up with a proposal to do something, they'd go, well, that's interesting, and after I spend, you know, $6 million, when am I going to get my $6.5 million back? When? You know, I don't want to, you know, if I spend $6 million over 3 months, I don't want to wait 3 months to get that other $500,000 back. You know, I want it now. So you want a compelling value proposition, get everybody focused, and turn the corner very fast. Take it, grab the money, whether or not it keeps on coming or not, depends on the market. Yes, one more.
Oh, yeah, I was wondering, when you were talking about making the code or use cases and the code testable, were you talking about like continuous integration and have a coverage of your test environments?
Yeah, that's very important, particularly when you're doing these dynamic random updates. Okay, really important. You got to bring the data together. You got to bring your computations together. You have to scale them out, right? You have to schedule them. You have to and you're going to be continually doing continuous integration, right? You're bringing in new feeds, right, with new computations, right? So yeah, that's key. I was saying before, I just alluded to that. You know, you're really building micro data services. This is a software engineering problem, so you got to treat it like that. Any more? Yes.
Inside a BigQuery, the unstructured data or the NoSQL data is stored in which format, like data dictionary or like hash tables or like graph-like structure?
Well, you can have, well, they all go into what they call an entity. It has the appearance from a user's consumer standpoint of being a table, okay? But we had text fields, very long text fields embedded in entities with 78 other numeric values with it. Time, values, other numeric measurements of an account. So I've seen the blending of the two. We initially started with just the text, okay, just the text field to start discovering this dictionary. And then when there were other factors that were correlated to, we started appending them onto that structure. And it got quite large after a while. So I was saying you can really start looking at a large variety of correlated facts or properties together and extend that model quickly, very amenable to that. Like I could do the select, grab the, merge the tables together in a matter of seconds and get the data sets. That to me was, when you start looking at doing these types of problems, you really got to have productivity, right? And one thing that can drag the whole team down is getting that data together and merging that data together. It really drags everybody. You really just, you know, I call it time to twiddle your thumbs. You know, the very first time, it's just funny. I'll end on a little joke. It's true. I put this data in, and I was going to run my very first query, and I'm told, hey, this takes us hours, man. It takes us hours. So I put the query in there. I got it. I did it, and I'm going to go and get a cup of coffee. And I put the query in there, and it's starting to react. Wow. 14 seconds later, I had it all. I didn't go get a cup of coffee. I go, now I'm going to try to write this thing, read it, only write it the way I want to read it, see how fast I can get it. Boom. 4 seconds. Boom. That, I mean, I actually called him up. And I said, you won't believe it. I can't explain everything I'm doing today, but let me share with you something. You know, I was, you know, mentored by Epstein and Hoffman, the guys who created SQL Server. I was their MVP on Wall Street. I mean, I've been deep into this stuff. So for a person with my background to get that type of pleasant shock, you know, was a nice experience. I had literally never had anything respond back that fast, ever. And I really wasn't pushing it. I just took a third normal form structure, 10 table joins. Each of them had 10 terabytes into it. 10 table join. Boom.
How does that compare with AWS?
Well, I had done I look back, I took a large SQL Server cluster database, and I ported it up into Redshift. When I did that, I was very pleased with what I saw. Now, that it just happened that the structure in the SQL Server was really best supported by a columnar data service, not a relation. Okay? So when I looked at the structure and I looked at their use case, I'm going, wow, this really does belong in a columnar, not in a relational. Let's go off and do it. Very pleased. Much faster response. But I've seen with Spark even better improvements. So right now I'm looking more at going with Spark because it really blends. I think it creates a better environment for the people, data scientists to work with. Yes, sir.
Do you realize this is going to ruin the opportunities to go for coffee, for lunch, do other things?
Put your
The person
thumbs
really
on,
wants to
yeah,
do it.
Just crack that whip, keep them going.
Yeah.
All right.
Charles, thank you.